Hello, and today we're going to be doing 1.4, which is quadratic equations and applications. When I talk about quadratic equations, it's usually parabolic in nature, so you have some sort of x squared situation going on. Now, there's about 5 ways that are common to solve these. Extracting square roots, factoring in the zero product property, quadratic formula, completing the square, and graphically. We're going to touch on the first 4. We're going to kind of skip graphically, but how you would do it is you'd get y equals your parabola, you'd graph it, and your answers would be your x-intercepts. So in this case, you'd have two solutions. Here, if I did something like this, you could have, one solution because the vertex is on the x-axis. Or, of course, you could have no real solutions up here, something like that. So that's how you would do it graphically. Like I said, we're going to focus more on the algebraic here. So the first one is extracting square roots. So if you get something like x squared equals 16, you're going to solve through square rooting. So for example, if we square root, we get x equals 4. Kind of. Whenever we manually square root, you have to take in consideration positive and negative. So my answer would not just be 4, it would also be negative 4. Here, we would divide both sides by 5 first. So I get x minus 2 quantity squared equals 25 divided by 5 would be 5. Now we can square root. So I get x minus 2 equals plus and minus the square root of 5. Should we note it's important that square root of 5 doesn't work out naturally, so I'm actually going to leave it like that. And of course, we can add 2. 2 is not combinable with the square root of 5, so I'm going to put it out front, so we get 2 plus and minus the square root of 5. Now, what if we had something that does have a perfect square that works out nicely? For example, x minus 2, let's do something else, x minus 3 squared equals, let's do 2x minus 3 squared equals 32. Well, first we would divide by 2, just like we divided by the 5 earlier, and we get x minus 3 squared equals 32 divided by 2, which would be 16. As we talked about earlier, 16 does have a perfect square root. It'd be 4 and negative 4. So let's x minus 3 equals plus and minus 4. Now, the most common mistake that I see on a problem like this is students want to add this 3 right away. And they would say that x equals plus and minus 7. Unfortunately, that doesn't work. What you have to do, if you get a situation like this, it's a perfect square root, is you need to break it up into 2 separate problems. So you'd have to write it out as x minus 3 equals 4 and x minus 3 equals negative 4. And you would add the 3 independently. So this first one, we get positive 7, which is absolutely true. But adding this 3 to negative 4 does not give me the negative 7 from earlier. That would give me negative 1. So, well, that process would get you one of the solutions. You have to remember that you get 2 separate individual solutions. Next one, factoring in zero product property. Probably the most common way you've solved these. Zero product property just means that technically speaking, A times B equals 0 if and only if A equals 0 or B equals 0. What that means is, conceptually first, let's factor. What multiplies to 12 that adds to 7? Well, that would be x plus 3 and x plus 4. In order for these two things being multiplied together to equal 0, either this has to equal 0 or this has to equal 0. So we set them both equal to 0 to solve. And minus 3, minus 4, we get x equals negative 3. and x equals -4. So if I plugged in -4, for example, I'd get -4 plus 3, which is not going to be 0. But here I get -4 plus 4, which is 0. And therefore, this thing that's not 0 times this thing that is 0 would give me 0 as well. If I plug in -3 plus 3 would give me 0. -3 plus 4 would give me not 0. But 0 times not 0 is still 0. Over here, you get a little trickier one. So I would factor by grouping because a is not 1. So I'd multiply a times c to get 2 times -2, which is -4. So now I'm trying to find something that multiplies to -4 that adds to -3. Well, that would naturally be -4 and +1. So I'm going to rewrite the expression. My first and last term stay the same. And the -4 and 1 go in the middle, replacing my -3x. Now, if I were to combine like terms, the blue things in the middle, -4x plus 1x, that'd be the same thing as -3x, so those have equal value. Now, factor by grouping, you need an even number of things. Here I have 1, 2, 3, 4 terms. So I group the first two together. What can I factor out of both of these? That'd be, of course, 2x, giving me x minus 2. Factoring being a division process. So what can I divide these two by? Just 1 for x minus 2. So I get the matching pair, x minus 2, and the outside pair, 2x plus 1. And I could set both of those equal to 0. So we get x equals 2 after solving it, and x equals -1/2 after solving it. You can't get the same matching pair right here. Then they are not factorable, and that's okay. A common way that students feel comfortable with is the quadratic formula. Remember, it's got to be in standard form, so it's got to equal 0, ax squared plus bx plus c, where we use this formula and just identify the terms. So the first thing we would do, minus 5, 3x squared minus 6x minus 5 equals 0. So we have our a, our b is -6, and our c is -5. So plugging into the formula, -6 plus and minus the square root of -6 squared minus 4 times 3 times -5 all over 2 times a, which we know a, is 3. We should do as much simplifying as we can. -6, that's going to be +6. 2 times 3, that's 6. -6 squared is 36. -4 times 3 times -5 is +60. Another common mistake I see is kids do this. You cannot do that, so please don't. Combine like terms in the radical. Okay. And then 96 doesn't have a perfect square root, so I would try to simplify that as a radical. So a couple ways you can do that. You can divide it by perfect squares. In this case, 16 and 6 is the same thing. 16 has a perfect square root of 4, so this turns into 6 plus and minus 4 square root 6 over 6. Or if you don't recognize that, you can always break it down with a tree. So things that multiply to 96, for example, you could say 2 and 48. Which would be 2 and 24, which would be 2 and 12, 3 and 4, 2 and 2. And because it's a square root, this index number, the number right here, is implied to be a 2. So I'd look for pairs of numbers. Those numbers get multiplied on the outside. So 2 times 2, which is 4. And any number that's not a circled pair gets multiplied and stays on the inside. So 2 times 3 gets stuck on the inside, so I get 6. So it's just another way you can break down radicals. Now I can divide. So when I'm trying to divide these, I need these three numbers to be divisible by the same thing in this little triangle. I can divide all those by 2. So divide by 2. So we would get 3 plus and minus 2 square root 6 all over 3. Next, we of course have completing the square. So completing the square involves identifying our b term, dividing it by 2, and squaring it. So here, we'd recognize that our b term is 10x. Now, I've always done this where I get rid of our c term or our constant. So let's start by subtracting 7 from both sides. So we get x squared plus 10x. I'm going to leave a little space here. I'm going to go equals negative 7. Here, let's identify our b term as 10. So we're going to do 10 divided by 2 quantity squared. 10 divided by 2 would be 5. 5 squared is 25. So I'm going to add 25 to the left-hand side. Well, if I do something to one side of an equal sign, you have to do it to the both to maintain equality. So I'm going to add 25 right here as well. This side's easy. I can just combine that into 18. This side is interesting. It's called completing the square because this actually now factors out perfectly. Because if I look at my original x squared plus 10x plus 7, that doesn't factor. Nothing multiplies to 7 that adds to 10. Well, now what multiplies to 25 adds to 10? That would of course be 5 and 5. So I get x plus 5 and x plus 5. And this pattern is actually really nice because I can write this as x plus 5 quantity squared. That's the whole point of completing the square. It's now a perfect square thing. And also, this 5 is really interesting. Did we talk about 5 earlier? We absolutely did with this 10 over 2. So the pattern actually turns into x plus b x plus b over 2 tends to be what gets squared there. Anyway, we have x plus 5 quantity squared equals 18. So let's keep solving. Square root, square root. 18 doesn't have a perfect square, but 9 does. So I can do this as a square root of 9 times the square root of 2. So we get x plus 5 equals 3 root 2, but plus and minus. 3 because 9 has a perfect square root. Minus 5 minus 5. Negative 5 can't be combined with this, so you keep it separate. Now, the next slide is the previous problem from earlier with the quadratic formula. I'm okay with whatever methodology, sorry, this problem right here. So we should get the same answer if we were to work our way through it. I'm okay using whatever method you feel comfortable with. I just want to get us started on this one and the process would be the same. So if I get something like this, I want to factor out whatever I can, but not variables. Normally we'd look at this and we'd agree you can factor out a 3x. I'm just going to factor out 3 here. So that gives me x squared minus 2x. Again, I'm going to leave a little bit of space, equals 5. And then again, I'm going to do b divided by 2 quantity squared. But my b term I'm going to do is now negative 2. So negative 2 divided by 2 squared. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I'm actually going to add 1 right here. However, technically speaking, I'm not going to add 1 to the right-hand side. Why? Well, inside this parentheses, this is a 1. But what could I do with this 3? It could be distributed. So, mathematically speaking, I'm actually adding 3 to the left-hand side. So I would add 3 to the right-hand side. Factor the inside. We get 3x minus 1 squared, which makes sense. Negative 2 divided by 2 gives me negative 1 equals 8. Divide both sides by 3, divide both sides by 3. X minus 1 squared equals 8/3. Square root. I'm square rooting a fraction, so I'd square root the top and the bottom. 8 doesn't have a perfect square root, but 4 and 2 can be broken down, so I'm going to get x minus 1 squared equals plus and minus 2 square root 2 up top over the square root of 3. Oh, sorry, we square rooted, so I don't have that square anymore. We have to rationalize the denominator. So x minus 1 equals plus and minus 2 square root 6 over square root 9, so 3. Because remember, anytime you have radicals with the same thing, you can just multiply them. So square root 2 times square root 3 is square root 6. And of course, we can add 1 to both sides. I want to add it to this fraction, so this needs to be a common denominator. So that would be 3 over 3, which I'm going to put right there. So we get x equals 3 plus or minus 2 root 6 over 3, which is exactly what we got 2 slides ago. 3 plus or minus 2 square root 6 over 3. So completing the square is completely optional. If you feel more comfortable with quadratic formula, do that. The thing with the quadratic formula is it can be sort of slow and meticulous, but students tend to have more comfortable with that. Completing the square, if you get really good at it, is going to be is a lot faster. All right, let's try some problems. A rectangular sunroom is 3 feet longer than it is wide and has an area of 150 square feet. Well, it's rectangular, so I know A equals length times width. And we know that it's 3 feet longer, so my length has to be 3 plus W. I'm just going to use W for my width. So we would get 154 equals 3 plus W times W. We can, of course, distribute the W. So 154 equals W squared plus 3W. We can subtract the 154 from both sides, and we can solve by factoring. So what multiplies to 154? Negative 154 that adds to positive 3. That would, of course, be W plus 14 and W minus 11. Not X minus 11, W minus 11. Set them both equal to 0. We get W equals negative 14 and W equals 11. Well, conceptually speaking, we're not going to have a negative 14 for our width, so W is going to equal 11. And length equals 3 plus W, so length is going to be 14. Next one. A construction worker accidentally drops a wrench from a height of 235 feet and immediately yells, "Look out below!" Could a person at ground level hear this warning in order to get out of the way? Speed of sound is about 1,100 feet per second. So speed of sound, distance equals rate times time, solve for t. Now, this equation right here comes up a lot in a couple different iterations. This is all about free fall. S is height. T is obviously going to represent time. Same with this T. V sub 0 is velocity at the start. So start velocity. And S sub 0, well, if S was height and V sub 0 was velocity at the start, S sub 0 is height at the start. What that subscript of 0 means is when our independent variable is 0. In this case, my independent variable is time. So all that S sub 0 stands for is time at 0. That's all that's talking about. Well, looking through it, the wrench was dropped from a height of 235, so it started at 235 feet, but it was dropped, so it has no initial velocity, so 0 goes in for right there. And the question asks, when will it hit the ground? So ground has to, of course, be my final position. If you want to think about it as height final, that's perfectly fine, which ends at 0. So we're just solving that side. To get t would be about 3.83 seconds versus over here, distance equals rate times time. Solve for time. That's how we get divide by r, d over r. 235, but feet per second, so that one would take 0.21. So of course, people would definitely hear it before the wrench actually hits the ground. Last one, you construct an open box from a square piece of material by cutting 4 centimeter squares from the corners and turning up the sides. The volume of the box is that, I believe it's 4, right? Yeah, 4, sorry. 576 cubic centimeters. Find the dimensions of the square piece of material that you use to construct the box. Well, volume is length times width times height. And we know that this is a square piece of material. So I know that my new dimensions have to be equal to each other. I don't necessarily know what they are, so for the sake of argument, I'm going to call my length x and my width x, but I do know that when folding that up, I have a height of 4. So I can write this as 576 equals 4 times x, or 576 equals 4x squared. From there, we can divide by 4. We get x squared equals 144, square root, x equals plus and minus 12, but obviously it's not going to equal negative 12 centimeters, so I can do just positive 12 centimeters. Thank you for listening, and I hope you have a wonderful day.